assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
Okay, so the question was asking us to determine the magnitude and the direction of the net force on the loop. Well, first, let's introduce an equation, which is F equal to mu 0 over 2 pi times I2, I1 times I1 times I2 over D times L. Okay, so this is the equation for the force. And mu 0 here is the permeability of a free space. I1 is the current in wire 1, I2 is the current flow in the second wire. Okay, and L is the length of wire 2, and D is the distance between the two parallel wires. Well, since the net force on the rectangular loop due to currents carrying wire placed next to the rectangular loop is the difference of the force acting on the loop on the nearer side and the force acting on the loop on the farther side. Okay, therefore we have F net force is equal to the force on the near side minus the force on the far side. Okay, so we'll have mu 0 over 2 pi times I1 I2 over D near times L near minus mu 0 over 2 pi times I1 I2 over D far times L far. If we do some arrangement, we'll have mu 0 over 2 pi times I1 I2 L is equal to times I1 I2 L times 1 over D near minus 1 over D far. Okay, and why we can arrange such equation is because the length of the near side wire is equal to the length of the far side wire. Okay, and then we know D near, which is the distance between the wire and the nearer side, is D near. Okay, which is 3.0 centimeter. If we convert it to meter, it's 3 times 10 to the power negative 2 meter. Okay, and the distance between the wire and the farther side of the loop is 3.0 centimeter plus 5.0 centimeter, which is 8 centimeter. And if we convert it to meter, it's 8 times 10 to the negative 2 meter. Okay, so now if we plug in all these values, we have net force is equal to mu 0 over 2 pi times I forgot to plug in the value. Sorry about that. So it's the permeability of the free space is 4 pi times 10 to the power of negative 7 Newton per ampere square. Okay, over 2 pi times I1, which is the currents in the wire 1, which is given as 3.5. So it's 3.5. Let me see. Times 3.5 ampere, and I2 is 3.5 ampere as well. The current on wire 2 is 3.5 ampere as well. Okay, times the L, which is the length of the wire, which is 10.0 centimeter. Okay, so times 0.1 meter, and then times 1 over, let's say 0.03 meter. You know what? Let me put it on the next line. It's kind of tight here. Sorry about it. So let me write it out. So this will give us F net is equal to 4 pi times 10 to the power of negative 7 Newton per ampere square over 2 pi times 3.5 ampere times 3.5 ampere times 10 centimeter, which is 0.1 meter, and times 1 over 3 times 10 to the power of negative 2 meter minus 1 over 8 times 10 to the power of negative 2 meter. And this will give us the net force is equal to, let me double check, it was 501, I'm sorry, 5.1 times 10 to the power of negative 6 newtons. Okay, so now let's determine the direction of the force, since we got a magnitude of the force. Okay, so the force on the near side of the loop is toward the wire. Since the currents are in the same direction, therefore the force on the farther side of the loop is away from the wire, as the currents are in opposite direction. So therefore, the direction of the net force on the loop is towards the wire. Okay, so let me write down towards wire. Okay, and this is the answer for the question. Thank you.